Welcome to the uh, Monday edition of Astro Cafe for the Victoria Centre of the Royal Astronomical Society of Victoria. My name is Reg Dunkley, and I'll be the host this evening. We're going to have a little bit of a different type of uh, meeting tonight because over the weekend, we lost one of our remarkable rascals, Sidhu, and messages being sent out on our email to most members. So I would think that most people have heard about it. And Dan Posey wrote a very good letter about this. So what we were thinking of is that we'll eventually have a probably get together of everybody so they can exchange anecdotes and reflections and memories of Sidhu. But before we start our formal part of our meeting tonight, we thought that we would give people an opportunity to express some of their memories briefly about Sidhu if they have a moment. Now, Joe Carr has put on his website let's see if I can share this. So chat and share. And see if I got this. He set up a nice, whoops. Sorry, folks. I'll just get back to a home position here. He put up a memorial thing here, and if I read more, he's got a nice photo catalog of Sid here, together with Chris and Randy from the last AGM. And there's some images here of Sid. And he had a remarkable impact on our society. For over 40 years, he's been an active member. And I'll just reflect what one briefly thing that I have is that whenever I saw Sid, he said, "Hello, young man."
Yes.
And
Yes.
even though I doubted the accuracy of his assessment, it did make me feel better. And I think the reason that it made me feel better was Sid was so enthusiastic and energetic, and it was contagious enthusiasm. And I really always enjoyed working with Sid. And that is one thing that he brought to the center to me. And I'll leave that as my overwhelming comment about Sid. But I've only known him for 13 years since I've been here. A lot of people have known him for many decades. So if anybody else has something they would like to share or some ideas or comments or reflections, please raise your hand and we'll allow you to participate.
I've got my hand.
I see Marji raised her hand. Marjorie, you want to go ahead?
Yes, Sid said the same every time from the moment I met him. He always said to me, "Hello, young lady." And I always hugged him.
That was a pretty effective strategy. David Lee, you raised your hand.
Yeah, I did. And, you know, Sid certainly was a long time friend of mine. Um, I still don't really believe it yet. But as the moments have been passing by since, I've had these kind of flashbacks, of the quirkiness which was Sid. And for some reason, I don't know why, but for some reason, my mind went back to our monthly meetings up at UVic, and I remember everybody would be reporting out, and Sid had been our long-term librarian, right, before Alex took over. And he would say, like everybody would be giving their reports, and you would think, Sid would just get up and there would be this long pause, and then he would just say, borrow books. and 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 it cracked me up every time. But anyways, that's my memory.
Okay, Garry?
To echo you guys, you had to smile when Sid came up and said, "Hello there, young man." Like, seriously, I didn't give him a hug, but I should have.
Um, Chris?
Okay. Yeah, I think at first yesterday I didn't quite believe it, and I woke up this morning and was thinking about it quite a bit. You know, yeah, yesterday I was having a conversation with David Lee, and we were talking about pictures. And David was saying, "Well, I was having difficult. I've got all sorts of pictures of Sid, but he's always in a whole group of people. There aren't that many pictures of Sid, just as Sid. And I think that kind of says uh, a lot about him. Um, and I also think to back to the banquet we had earlier this year. Um, I actually can't remember who had this idea, but anyway, um, uh, usually when you receive the Newton Ball Award, you get it once, and that suffices. But anyway, the council earlier this year, when I was still president, um, decided, there's just, Sid is somebody who's just so special, even though he got the Newton Ball many years ago. We got to give it to him again. And so and I'd actually forgotten about that yesterday, and then found this picture that Joe has put up um, of Randy and I making that presentation earlier this year, and I thought back to that, and I can't remember exactly what I said, but basically, I think what I did say was kind of the feeling I had is just, what can we say about you, Sid? We just all love you. You just every time we had an encounter with him, it was always a positive thing, even if sometimes the situation was difficult. And he was just one of those people. You think of him and people like Diane and all that, but Sid was here was with us for a long time. I was reading some of the stories about when he uh, had the asteroid named after him, and he said that he had a bit of an epiphany when he was observing in 1983, and a couple of years later, he joined our ranks. So he was with us for about 40 years. Um, I turned up in Victoria about 10 years later, and a number of other people like David showed up at similar time, and um, so he did practically, over the years, he did practically every job there was to do except one. We almost got him to be president. I remember a few years ago, we practically talked him into it, but and I can't remember what happened, but he never took that job. But he did everything else, so he maybe didn't have that particular position, but he was one of the leaders uh, of our group, particularly in things like public outreach, and and next year when we do Astronomy Cafe and the Star Party and things like that, or sorry, Astronomy Day and things like that, I'm going to be looking over my shoulder and wondering when Sid is going to be tapping me in the shoulder and encouraging me, or when he's there with that counter. You know, every time I think of that counter, um, I think of Sid, you know, and I joked with him, you know, that uh, when we reached the day that unfortunately we reached yesterday, I was going to bury the thing with him. But I know that would be the last thing he would want to do. He wants us to keep using that thing. And he will be tapping us on the shoulder. So one other thing I will say is that, you know, Sid was a giant within our center. And in a lot of ways, he wasn't that well known at the national level, but he got kind of an unusual recognition um, uh, at the national level for his work. And in 2010, 15 years ago, the late great David Lane was president of the society, and he created a new award called the President's Award, which basically allows the national president to just give an award to somebody who's done a lot for the society, and it didn't matter what it was. And so he chose as the first winner of that award, Sidhu. Um, and and I thought that was interesting because, you know, Dave lived in Halifax, about as far away as you can get from Victoria. And yet he knew about Sid. I know he had been out here, you know, during his presidency, but I thought that was a really interesting recognition for the work that Sid had done. So I think I'll leave my remarks for tonight there.
Have we lost our host?
I saw a thing that said David Payne is now the host.
Oh yeah, that's weird. I don't know how that happened. You could take it back though. You should be able to.
Do we want
Re
Susan to go ahead?
I'd like to go ahead. I met Sid last year, was wanting to borrow a telescope, and people said, oh yeah, you need to get in touch with Sid. So I drove out to the back and beyond of wherever it is, Langford or Colwood or something. That was sort of the first time I really encountered him. And he had his garage open and he brought out a few things. And my experience of him was that he was a gentle soul. I wanted to hug him. I mean, he was that sort of person that sort of invited the desire to hug. And I found that he was very, very clear in his instructions about what I was to do. And I still have what I borrowed, so I'm wondering what I'm supposed to do with what I borrowed, but that's for later problem solving, I guess. And then the last time I saw him was at the Saanich Fair when he brought the counter and was reminding us to count. So that's what I need to say. Thank you.
And I will just kind of go in with something else that Sid always used to say. And when you were if he had you sitting down or close by the telescope, he'd always say, now relax. he'd say. Sit down, sit yourself down, relax, take a deep breath, he'd say, before you tried to see anything through the telescope. And I will remember that forever. So yeah, it's been a pretty tough couple of days. Thank you.
So we missed some of the comment. We caught tail end of Susan's remarks, and we heard Lauri's remarks here at the Fairfield Community Center. And we might have lost some of Chris Gainor's remarks, but Chris reminded me of, he mentioned that Sid had been done in pretty much every job, but Sid was a long haul performer. He set the record for 20 years as the librarian for the center, and he was the director of telescopes. That was his last official position. He gave up yesterday for 30 years. So he's a person that take things on and stay with them. And I guess we didn't make a big issue at this time about his devotion to education and to outreach and that much, but those were two really key things that he was passionate at. And before we go on, I just wanted to say this read from the note that is on our webpage, just written by Dan Posey. He says, Sid was a stalwart of everything good about RASC. He was an unwavering champion of our school program, a tireless supporter of public outreach, and a cherished friend of so many of us. His contributions to our center and to astronomy education in our community are immeasurable, and his absence will be profoundly felt. And I think that's the way we go.
That when Sid was doing public outreach, he never really thought very much about putting out a message and saying, hi, did anybody want to help? Sid would get on the phone and he would phone you and say, like, what are you doing on Saturday the 30th? I need you at 2:00. and you didn't have very much of a chance to say no. So he was able to just kind of conjure up from almost everywhere people to do all kinds of things. And he would have no trouble getting people to come out at nighttime to be at a star party with a group of running around kids at a school, and he'd just be thrilled to death to have people doing that kind of thing for him all the time. So he was really good at getting everybody involved, and he was very good about getting new people.
Which one
as
is
well.
Sony?
New people involved in the center. So
this is a Sharp. That was the Sony.
Oh dear. Yeah, I'd forgotten about that, Lauri. Thank you for that good memory. Yes, he'd call me and say, hello, young man, I want you to check your calendar. And he'd just say, yes, I wonder what he's
Your
got
fingers in the way, I
now.
can see.
Steve Robinson would like to have a few words.
Yeah, this has been a tough year for me as an astronomer. I've lost two of my good friends in the same year, with Bruce McCurdy in April, and now Sid. I first met Sid, I'd say at least 30 years ago, when I was director of electrical engineering with Alberta Public Works. Sid was my counterpart with the BC Buildings Corp. And I met him through a former colleague in Edmonton, Alex Zimmerman, who I notified of Sid's passing today. So I got to know Sid through engineering side. And then when I moved down here, it was just natural to become a close friend with Sid. I always respected him. I loved him as a friend. We also know his wife very well because my wife and I sing with the Victoria Choral Society. And Carol was active in that society for a number of years. So we're all going to miss him.
At any rate, we'll go to the main portion of the meeting right now. And we have a number of people who have volunteered to speak. Phil is going to give us, Phil Stooke is going to talk about the Interstellar Comet C3I Atlas. And we talked last week how Perseverance took a picture of it. And so the first thing we'll have is Phil giving his presentation. And then I'm going to give a little talk of low-tech photographs of Comet Lemmon. And then Randy is going to give some examples of high-tech comments of Comet Lemmon. And Dave has got an image. And one of our new members, Vince, has got some really nice images that he would like to share. Vince is in the room here, so you'll meet him shortly. And after that, Randy has a talk on Aldebaran. And is there anyone else who has anything to share tonight that they would like to share? Seeing no hands, I guess we will go to Phil.
Okay. Yes, so last week we saw, we had some more details about the comet and mentioned that Perseverance was going to take some pictures or had taken some pictures. So I just thought we'd have a look at them. But they're not terribly exciting. First, the rover takes images and does all its other things. And every time one of the orbiters flies overhead, it uses that as a relay to transmit data to Earth. When that arrives on Earth, a copy of all of the images is automatically routed to a raw image page, which is hopefully everybody's able to see here. And that's happening automatically, so it's not affected by the government shutdown. And new images appear every day from Mars for Perseverance and for Curiosity. However, because of the shutdown, we're not getting any information, any reports from the mission, anything like that, that will tell us what they're seeing. However, I went to the page for the appropriate day, and let's go to the next slide there. And here's a raw NavCam image. So these are pictures from NavCam, which is the navigation camera for the rover. It's a relatively low resolution, wide angle camera, and it's designed to take panoramas of the surroundings every time the rover stops, so that they can plan activities. And then the science is done with higher resolution cameras. So here is one of the raw images, and there are many of them. There are dozens and dozens and dozens of these nighttime images that have been taken on successive nights looking at the comet. This is one of the most interesting, and you can see, hopefully, there's a little bright streak, and I regret to say that that is not the comet. That's Phobos, one of the moons of Mars, which just happened to be crossing the frame when this picture was taken. Most of the other frames are featureless. Now, the question is there something else hidden in that image? And if we go to the next image, well, we can play around with contrast. Let's go to the next one. Despeckling, all sorts of things like this, messing around with the image. But the fact is that I don't think NavCam sees anything at all. I looked at the higher resolution images from the Mastcam. Let's go to the next slide. And they also look pretty much featureless. However, I've just seen, and I haven't had time to show this here, I have just seen a comment from somebody through social media saying that they are seeing something in these high resolution images moving across the field of view. And it's not clear whether that is the comet or not. I don't know. I was surprised at how quickly it appeared to be moving, but hopefully we'll get more information about that maybe by next week. I don't know. However, what I would say basically is that Perseverance is never going to be very good at looking at the comet anyway. They've done it out of interest, but
the cameras are not really optimized for this kind of work. And you are looking through a dusty atmosphere and so on. It's not going to be ideal. But let's go to the next picture. Much more effective is the potential for using cameras in orbit above Mars. And this is a little animation of frames from the European Space Agency's Trace Gas Orbiter. It has quite a nice multispectral camera. And here we can see the comet. Maybe you can just see that there's a little bit of fuzziness around it. And if you take multiple frames and add them together, if we go to the next picture there, that's the comet. It's seen by the Trace Gas Orbiter camera. Mars Express can take higher resolution images, but it can't take long exposures. And its images appear to be completely featureless. So that's basically where we are. The truth is, you are never going to get great results from Mars, even though the comet is closer to Mars than it is to us, because you simply cannot beat the value of having a great big mirror. Those big telescopes in the southern hemisphere and the big telescopes in orbit like Hubble and the James Webb, they're going to get much better pictures. These things which are designed to look at the surface of Mars from a few hundred kilometers away are never going to give you the same results as those great big mirrors. So that's it.
Okay, Phil.
Yeah.
The magnitude here is something like magnitude 11. When it's only, what is it, 0.2 AU away from Mars, would it be much brighter, or is it still down in the...
I'm afraid I don't know the answer to that. Sorry.
Well, thanks very much for taking the time to dig into that. And I don't feel that bad about my pictures now. I'll show mine next if you can. If I can show. So this is a picture taken at 4 a.m. on October 14th from my balcony looking up. And this is the handle of the Big Dipper, and that's the double star Mizar there. This was taken with my handheld, and it's quite remarkable, the detail you get with that. So I'm just going to blow this up and see if I can increase the screen here. Turn off the volume. Look at the back. So this is a little bit of a blow up. So here's Mizar here. This is the Canis Ventici, is it? This is the constellation with just 2 stars in it. And the comet is right here on the 14th. And the moon was 44% that time, and this was a 3-second exposure handheld. And if I
handheld,
yeah, about this by my hand. And so here is the location on the 14th. This is from Sky Safari, and you can see the one main star here is Cor Caroli. That's the primary star in this constellation. And if we zoom in here, there's the one star. That's Cor Caroli. The second star's got a neat name, but I forget. This here, if you look at it, it's kind of pitiful, but it's got a fuzzy little tail there. So, at any rate, so that was that. So I was quite pleased with myself. So 2 nights later, I got up at 5 a.m. Whoop. And I took this picture.
Whoa.
Now this was taken, this is a cheap man's way or frugal astronomy way of taking pictures. I didn't want to drag my telescope tracking mount out of the bedroom at 4 in the morning. I thought that wouldn't be a wise idea. So I just put I have a 360 millimeter focal length refractor that I attached to my Canon T3i, and it's not tracked. I just put it in the sky, and I centered it, and I started taking pictures. First of all, I did 5-second exposures. Everything was blurry there. Then I did 2-second exposures, and that was even a bit too long because you see these stars are actually little lines here, and the optimum focus was around 1 second. So I took 16 2-second exposures and I stacked them up, and you could get a little bit of tail there. Unfortunately, the whole thing started to migrate to the northeast as I was doing this, and I was running out of space in my camera. So that was kind of the weakness of this technique. But at any rate, you don't need to have a tracking telescope or a mount to take these pictures. So that's with that one. And then the next night, a few minutes later, I took it with 1-second exposures. And this is 45 1-second exposures. And at the time I took the previous one, we did not have any indication there was any tail at all with this thing. But since then, all sorts of people got tails. So I didn't realize how long it would be. I should have done things more appropriately. But that star core Caroli is here, and the comet is there. And you can see that the stars in this case are dots rather than lines. So
are we still talking about the Atlas Comet at this point, or is this
No, this is Lemmon.
Lemmon?
Oh, pardon me, Comet Lemmon.
Because I was going to be very shocked to hear that had Atlas had a big tail.
Yeah. So what you can do with this is in PixInsight. In PixInsight, you can do a 3D monitoring of this, and this is the star core Caroli, and this is the head of the comet. And you can see the profile. You get a lot of information that if you just visually look at things, it doesn't tell you very much. It's just a blob. But this will measure that it's a much more abrupt slope in the leading edge of the comet, and then it gradually tapers off. And in this case, the tail wasn't very good at all. So that shows you that you can have fun with a comet just with a fixed telescope tripod and a DCL camera and take a bunch of pictures, not too long, stack them up and play with them. And with that, I'm going to sign off. And I'll be ashamed now as some beautiful pictures of this Comet Lemmon come up.
Okay. Well, actually, I'm really impressed what you did do. So that's great. So I just did some Facebook searches for Comet Lemmon, and they're not very organized. So let's just go through. And my thought at one point is I would put them in chronological order and see if we could see the change in the tails. Is everybody able to see here?
Mm-hmm.
Okay, so this was actually from the space station. I think that's just great. I just love thinking that they're looking at the same stuff as us. Mm-hmm. So here are a few pictures from the amazing Deborah Saravolo in Soyuz, using the telescope that her husband designed, and Reg, the other one's called the
16-inch Bowler and Chivens Cassegrain,
which is the same as what we have
yeah.
at the center of the universe.
Yes, the cousin or the twin of our telescope at the CU.
Anyway, so this one was done with the telescope her husband made. Peter, I believe is his name.
And that was October 7th.
And this is the 14th. And this was done with the 16-inch. Wow. And that just blows me away.
Mm-hmm. Oh.
We're definitely doing this in sub-ideal situation in the room today. Okay, so now it's going to be a bit of a random walk of things that people have posted in the Facebook. And they're all Comet Lemmon. Oopsie. So that's in Stonehenge. think that's in Colorado. No idea where this one is. 26. Okay, this is the one I want to talk about. So first of all, Gianluca Massi is in Rome, and he runs what he calls the Virtual Telescope Project. And whenever there's an eclipse or something, it's really a fun live cast. And he is so enthusiastic, and he says, "Hello, friends. Today we're looking at the splendors of the sky." And he's an absolutely delightful person. So he was live casting taking this picture, and a meteor happened to go by. So the red is nothing to do with the comet. If it were a binary, this is a, what do you call it? When two stars are close to each other and they're not related?
Optical
It's a
double?
virtual binary.
Virtual,
Anyways,
yeah.
that's what we have here. We have the tail of not the tail, but the trail of a meteor has gone through and is getting all pushed around by the wind, and you have the comet behind it. And there's all sorts of light pollution. It's a terrible picture in a way, but it's the most remarkable picture. And he, to impress Gianluca, saying this is one of his favorite pictures he's ever taken, that's something. So I really, really appreciate
it. Just
this.
think of the luck that these two independent objects are coaxial like that.
Oh. That's the same one, I think. That's a good one, eh?
I'm totally stunned by the length of the tail.
Yeah. And the details in the tail. So it's really, it's sputtering stuff out. And they also, oops, that's it. They also talk about how the solar wind is quite inconsistent. I'm just going back. Yeah, I'm not getting bored of this one.
It's turbulence. Eddies from the wind.
Hey, Randy.
Yeah.
On this particular picture, I can see 3 either satellites or 3 Saturns, one of the two.
What's the deal? I see them also.
I'd have a hard
Anybody
time.
have an opinion?
There's 4 of them, actually.
Yeah,
So-
I see them. I see them too.
Let's blow this up and see if we can see anything.
Actually, by the way, how much longer is the comet going to be in our realm?
Well, Comet Lemmon is moving very fast, 4 degrees a day. I tried to see it a couple of days ago, and it was already by Arcturus and very low on the horizon in the morning. So it's toast, I think.
Okay.
It's, but the other comet is really high.
Swan.
Yeah. We might have fun with that in the evening.
Here we go. No, that's not a very good one. What I'm hoping for is a nice map showing where it's going to be when. Although this looks like the sort of thing that I was hoping to do. Let's bring this up. So those are all different tails of the same comet. And so, yeah, turbulence in the wind and variations. And it should be getting brighter as you go through the time, too.
Is it twisting?
Could be rotating.
It could be rotating. I remember with Comet Neowise a few years ago, the Deborah Saravolo picture, you could actually see a spiral around the nucleus. Garry.
Yes, sir.
Your hand's up.
Oh, I was asking about the satellites. I mean, about the 3 Saturns. I guess I forgot to lower my hand. Sorry.
Yeah. And it's hard to tell with that picture, but it's pretty low resolution. Okay. Am I going on with Aldebaran or
We've got
other people
a
first?
couple of other people
Go for
to share first. Let's do Dave, you had an image you wanted to share?
Sure, it's kind of related. It's not of a comet, it's of a star, and it's not.
To chew.
Okay, is it coming through?
Nope.
No?
There, oh my goodness.
Okay, it's kind of hard to see, and I'll show you a better one in a second. But if you can see, there's a blue circle where my mouse is going around.
Yeah.
And inside there's a ion signal. It's an oxygen signal from a Wolf-Rayet star in the center that's blowing out gas. And it a bit strange, this particular Wolf-Rayet, because usually you see this oxygen filter, oxygen signal, and you see also a hydrogen, red, yellow hydrogen signal around it too. You do see a weak one in this molecular cloud in the background. But what might be throwing off a little bit is the stars. So I also have a starless image. And I want to show you something really neat. So here's with the stars taken out, and we can better see that blue bubble that's being blown. And if you can imagine, this bubble is traveling towards the left-hand side. And you can see it's buffeting and compressing with the probably atomic hydrogen media out here. So you and it's kind of making a big bow front too around this star. But what's really weird is if you look to the right, there is the star in outline in hydrogen alpha against this molecular cloud. So it's almost like it left this outer shell behind. And so it's really hard to explain, and I can't explain it fully, but I do have a suggestion as to what's going on here. And I turn to cartoons to help explain it. So we've all seen Bugs Bunny cartoons where someone runs through a wall and leaves their profile at the wall. Another example is Bugs Bunny going through a wooden wall, and he's coming back through, but he left his profile as he went through. So it's a profiled collision, if you will. I do have one more I could quickly show you with Roger Rabbit, but I think you get the impression here. It's something that generally only happens in cartoons, because when you break something, usually you create fractures that go in random directions according to the weakness. But this star seems to have come either out of this background molecular cloud that's it's not very bright. I've brightened it artificially, but and either punched a hole, and when it came out, it left the impression of its shell behind, or it's either gone into the molecular cloud. And generally, we can only see the surface of the molecular cloud back here. We can't really see the interior. But so I think it's actually outside the cloud now. But it's kind of a cartoon thing where it's left its profile. It almost makes a perfect profile of this star as it's come zooming out of the cloud.
So, David, if you look at the bow front, it looks like it's coming out. I mean, it's kind of like punching through and then it's flaring backwards, right? Towards
Yeah.
the opening.
There's a
So that would
very
make sense.
obtuse angle coming out
Yeah.
here and out here from the bow front. But how it made such a clean impression, and you have to actually process it carefully to see this impression, but it really sticks with the profile. So it's kind of a neat thing, and how this cloud is traveling more as a unit. I'm sure it's swirling and undulating, but it's traveling more as a unit. And these stars are basically immune from that viscosity. They're like a golf ball being hit through the air, if you will.
So David, how did you discover this? You imply that it was not very apparent, and you had to kind of focus on the area to see it, or?
Well, it's had a couple of mentions in the community, but
Okay.
There's no explanations for it out there, and so it gives me freedom to make up my own.
But David, if you're going to do anything with that, don't you have to attribute credit to Warner Brothers?
Well, yeah, as I was going through, Roger Rabbit actually did it too. Roger Rabbit came after Bugs Bunny, but Roger Rabbit did it through a pane of glass. I don't know if you got two more seconds. It's actually quite entertaining.
Just when you go to name the star, you have to name it WB something.
It's WR134, and it's in
Very close.
So I'll just play this for 2 seconds. So if you look at the second scene,
He took it well.
he actually went through the glass.
That's great.
So that's all I have there.
He survived.
Quite entertaining. But if you've got a better explanation, I'd love to hear it.
David, can I just ask? It seems to me that there was another even less, paler image at about 5 o'clock of your second image.
Oh, should I share again?
Yeah, sorry.
The starless one?
Yeah. No, you can go back. Maybe the starless one. Yeah. Sorry.
It's okay. Let me bring it up. Okay, where are you looking? This funny thing.
Oh, we're not seeing anything here.
Oh, am I not sharing? Oh, there we go.
Yeah. So if you look at the paler, like redder image, right?
This
Over
one here.
there. So look down at it about 5 o'clock. Keep going down, and right there, right, like just there's another kind of circle there to me.
Oh, you're right.
Another opening. Yeah.
Like right there.
Or here, or here?
No, just like the bottom of it is just kind of
Though you're right, David. I could be wearing one right at the corner. Look, go right down to
Oh.
the corner. Right there, yeah, up a little bit. Yeah, there's one.
Well, so these Wolf-Rayet stars, they do pulse. And I'm not sure what time frame that would be. Imagine it would be
Okay.
thousands of years. Maybe its whole trail is being etched in pulses.
Yep.
Oops, sorry.
Good pickup there, Lauri. David, you should send this into Astronomy Picture of the Day. They're always interested in new and different stories, as opposed to just another image of the Andromeda Galaxy. So this one would be good to send in, I think.
Send into who?
Astronomy Picture of the Day.
APOD.
Oh,
APOD.
APOD.
Yeah.
When it reappears again.
Oh, that's right too. I forgot about that. Yeah.
It's shut down right now, yeah.
Yeah, but they like good stories, and this is a good
Okay.
story, especially with the series of holes that everybody saw. That's kind of cool.
Yeah. I'm gonna have to image this again in the spring there.
Well, that's great, David. Thanks for that.
Thanks.
We've got a relatively new member. Vince is he showed up at the VCO the last session we had open. We had a great time talking about stuff, and while we were up there trying to download images, he was remotely connected to his computer, and he had his telescope set up, and he was bagging photons remotely at home while he was up there. So that was kind of an interesting experience for us. And so he's brought a number of images that he's going to share with us right now. So Vince, do you want to take the floor?
So this is my first summer as a digital deep sky photographer. I started off when I was very young. I was probably about 13, 14 years old. Got my first camera when I was 16 and my first scope when I was 16. But had kind of given up on the hobby because I got sick of freezing my behind off off-axis guiding hours of photography. And so a friend of mine had upgraded his camera and gave me his old one. So I have an ASI 294 Pro now. And this is my first summer in venturing into deep sky photography. So this is kind of in reverse order. So those first two I took.
If I click, will it?
Yeah, it should
blow up.
Yeah. So that is NGC 89891, I believe. And I snapped that one last night from my backyard. It's I think it's a 30-minute. It was a 30-minute stack, 30-second subs, just on Luminance channel. And it turned out quite well. I had hoped to stack a little bit longer, but then the clouds rolled in on me. So that was the last image of the session last night. And then the other image, NGC, it was one of those things where I just stuck my scope in a random spot and went, oh, hey, a galaxy.
Oh, great.
And then as the subs came in, I went, wait, there's a whole bunch of them in there. So this is up in Perseus, and
Is that Caldwell 30?
It kind of looks familiar, doesn't it, Reg?
I think it is, yes.
So I was quite enamored by it because every little dot, if I look closely, was a fuzzy spot. So it's like this region of a bunch of little galaxies. And so that's about an hour worth of subs at 30 seconds on Luminance.
That's even better than knowing what you're aiming for.
Yeah, but that's Caldwell 30, and then the little diffuse things off to the right are called the fleas.
Right.
And Caldwell 30 is about 40 million light years away. The fleas are 350 million light years away.
Wow.
They're not connected.
Yeah, they're not connected. So some
coexisted.
significant light shift
So
between
that's
the two of them.
pretty good shot, just randomly picking it up.
Yeah, it was
good for you, Ben.
It was one of those things where I had done my focus and I just kind of pointed the scope in one direction of the sky to try and calibrate where the scope's pointing, and sure enough, that's what I picked up.
So
Vince, remind us what your optics are. I can't remember now.
I have I call it the CompuStar. It's a CompuStar 8.
Oh, that's right. That's right. Okay.
That I have. I don't run the electronics anymore, except for when I do like a sidewalk astronomy. I've built my own electronics for it, my own guidance system, but I've kept it because the worm system is superb. Like my tracking is just is
Vince,
unbelievable.
If you come here,
Sure.
then they can see you.
Oh dear. I'm not sure if you want to see that. So yeah, it's an 8-inch. Yeah. Oh, it's an 8-inch CompuStar. I bought it when I was 16 years old. I worked for 2 summers on the oil rigs to afford to buy it. It was $18,000 in 1986.
Holy.
And I have kept it my entire life and worked it my entire life. So, except for a period for about 10 years when it had a Y2K bug. But yeah.
So when did you take this photo of?
This was last night.
Okay.
Yeah.
Because the interesting thing, on August 14th, there was a supernova near the center of called.
Oh, that's the one we were looking at.
Yeah. And so I have a number of images I collected to the VCO of it at various times. So unfortunately, I oversaturated the first images because you can't measure the magnitude of it, but it's a beautiful object. And the interesting thing with that is the center of the galaxy rotates in the opposite direction from the other galaxy.
Oh, interesting.
In 1996, they discovered it was a counter-rotating galaxy.
Huh.
And perhaps the supernova occurred in the shear zone between the two spirals. It was a really interesting thing. So,
the middle is going the opposite direction of the outside?
Yeah. Yeah. So there's a number of galaxies. Vera Rubin, when she was doing her analysis of the measuring the profile of the radial velocity as you move away from the center of the galaxy, she found a whole pile of counter-rotating galaxies. She didn't discover this one. This was discovered several years later in 1996. Fascinating subject.
I think that's
there's a
cafe talk.
Yeah.
There's a good explanation for that.
Oh,
why they're rotating. But you kind of blew it because I thought you were coming up with all these facts right off the top of your head. But then you said you recently photographed it.
What? I recently photographed it.
Is that what you said?
Well, I've got a series of images taken at the VCO of this from the summer until November or
I was just wondering how you knew all these facts off the top of your head.
It was a bit of a passion. So there you go.
And this is the elephant trunk, just in hydrogen alpha. Though I call it the dragon's head, just because to me it looks more like a dragon kind of coming out of the cloud than it does an elephant's trunk. This is one I had hoped to get the oxygen and sulfur channels, but I just ran out of space to track it in my backyard. I've got houses around me, so I've got a very limited chunk of sky that I can look at.
But aren't you fairly close to Hillside Mall?
I am.
Yeah, so I think you're doing really good.
Yeah, like Portal 99 skies pretty much. And I'm still pulling off some of these images.
So you can only do narrow band.
No, the galaxies were wideband.
Wow.
Yeah.
Sid
again. That is a Cygnus wall. And I got inspired to go try for that one after Dan had run the big telescope up at the VCO. And he showed me an image of the Cygnus wall, and I went, "Oh, I gotta go get that one." And so that was my next week of obsession. So that's SHO, it's narrowband. Each channel, I think I did 2 days on each channel, so or two nights. So be at that time of year is about we're getting about 6 hours, 5 hours of night. So 10 hours on each channel stacking, and I think I'd have to go look at my subs, but I think I was doing back then. I was still doing 10-minute subs on it, and I have it set up that it will track primarily with PhD2, but as the tracking moves, it will instruct the scope to reacquire and then retrack with PhD2. So I'm running a Sharp Cap with a lot of Python script. Yeah, it's sort of Sharp Cap, but with a lot else behind it. That is the Crescent Nebula. That is my first Wolf-Rayet star. Every person show it to has a different idea what it is. Some people call it the space brain. Some people call it the space jellyfish. What was my friend Roberta called it? It was the space beanie because it looked like one of those wool caps. So that was the first time I've ever did an object like that. That was very difficult for me because this was fairly early on and I was still getting the camera figured out. I did not understand things like offset at that point. So I was really having a hard time kind of pulling things out of the grass, as you will. But still managed to pull that off. I think that's about a week worth of subs on each between the three channels. And that's the Bubble Nebula. That's another one I accidentally found. I was on my narrowband and I just slewed to some random part in the sky and I started to see this bubble and what is that? This is really neat. And so I look, I actually went and did, how you can do the plate solving. And I was like, where am I pointing? And so I plate solved it, and sure enough, it's the Bubble Nebula. So I'm like, okay, I got to go do that one. Again, that's SHO. Most of these at this time, I was doing 10 to 15 minute subs. I've since kind of gone down in time. I've learned that you don't necessarily have to do these crazy long subs. Yeah, those are 15-minute subs and I think each one on that one I did 2 days or two nights worth of capture. And again, with Sharp Cap, running scripts to kind of keep it tracking. This is one of my favorites. So there are two nebulas that are the first nebulas I saw. I remember the first time somebody showed me through a scope. It was the Orion Nebula, and then that summer I saw this one, and I was like, "Oh, that's so cool!" So that was when I got the camera kind of working. That was the first thing I had to go after was, of course, the dumbbell. It's SHO. Kind of my early stuff, so I don't have the offset quite right. So I'm going to do a better job on it next summer.
It's really fun seeing you like going through this process.
Yeah,
that's great.
That's the Ring Nebula. Not the greatest shot, but this was probably a month into me having the camera, so still very, very beginner. And that was before I had any filters. I was like, okay, I got to take a picture of something. I had just gotten the camera that week. It was like
slumming
on
the moon.
Yeah, exactly. It was what do they call it? The rainbow moon? No, it's like the moon in the spring, the new moon of the spring. And so I captured it, and the colors came out funny because I did it as an RGB, but it was just kind of in my neighbor's trees. So each sub of each color was slightly different than the other. So I kind of got this weird rainbow, and it was like the rainbow moon. I'm trying to remember. It was a rainbow
That's
moon?
fantastic.
No, flower moon. That's what it was. The flower moon. And so it just kind of came out that way.
There you go.
Yeah. M51. That was, I think, the first deep sky object I went after because it was right up at zenith and easy to get. That's just done in that was before I had my narrowband, so I just did that in luminance. And I'm also very interested in the sun, so there's a few pictures of the sun on there. Another picture of the moon, slumming on the moon again.
But it doesn't have any rainbow on that one.
No.
Rather
Well, that was
disappointing.
yeah. That was earlier in the year when it was a little bit higher. So as you get into the summer, the moon kind of goes behind my neighbor's trees.
Yeah.
I think that was my very first picture right there.
Yep, that's the beginning.
Yeah.
Wow.
So that's the beginning of a new deep sky digital deep sky photographer.
Well, welcome aboard, Vince, and thanks for sharing those images. It's pretty exciting.
Yeah.
And a lot of people out in video Zoom land are applauding you there.
Well, thank you.
There you go.
Yeah, thank you.
No, that was really awesome.
Thanks, Vince. So you planning to join us on Wednesday for the astrophotography group?
I'm not aware of it, so I will, I guess. I'm still learning all this stuff.
If you could, I could get you the invitation if you
Perfect.
send your email.
Okay.
We'll make that.
If I'm a good boy, I have Vince's email because he emailed me, so I will connect you two.
Yeah.
Okay,
Sounds good. Yeah. But I'm hoping to go through whatever hazing ritual is required to become an MIC so I can start making use of that scope up at the top, because you would, if I had access to it, you'd find me there every clear night, and even some of the marginal nights I'd still try and go for it. So
Yeah, he tried to convince us to go last night.
yeah.
When he contacted us, it was raining at my place.
It was clear. It was clear. I got those pictures from my
Yeah,
backyard.
yeah. Good for you. Okay, so well, thanks for that.
You're welcome.
We all now have a presentation by Randy.
Okay. I'm sharing it a lot, but not just for me. That's good. I'm very happy to share for other people. Here we go. So, we're going to talk today about the Eye of the Bull, Aldebaran. And this is the third chapter of this book that is entertaining me so much, so I'm going to try to entertain you with it also. And it's Aldebaran, How the Color of a Giant Reveals Its Hidden Secrets. So chapter 0 of this one, or subsection 0, is Where Do You Find Aldebaran? And here's a John MacDonald photo. I love starting these talks with pictures from Zenfolio, and they're almost always John's. I hope he gets to watch these videos. I don't know if he's following the Astro Cafes. Anyway, we see Orion, and there's Aldebaran. Kind of the belt points its way there, and there's the Pleiades past it. And there's all sorts of legends about, like, Aldebaran is protecting the Pleiades from nasty Orion. The other thing is it's part of the winter hexagon, which is really easy to see in a light polluted sky. Sometimes all you see is Orion and the hexagon, and it's here. So the first remarkable thing about this star is its proper motion. So this goes back to Edmund Halley, and I love looking at old publications because, you know, you get all the S's or look like F's, Procephion instead of procession. and how they do this CT for equinoctial. Anyway, very cleverly, he took a look at the classic star charts of Timacaris, Aristillus, and Hipparchus, and then he remeasured their positions 1800 years later. And so he saw that the stars are moving around somewhat more than 25 degrees or somewhat more than 50 seconds per annum. That's what it says there. And the modern value is, 50.29 seconds per year. So that is as accurate as you can get. And just to remind you from chapter 1, which was about Polaris is the North Star for us right now, but the Earth is wobbling. And so that 50 seconds a year is that wobble. And that's what he was measuring. But then he said, all the stars that were in the old, that 1800-year-old catalog are moving together, except for Aldebaran, Sirius, and Arcturus. And then he quite amazingly reasons that they must be the really near stars to Earth because we can see them moving. If things are far away, then they won't seem to be moving so much as if they're close to us. So that's an amazing observation back in 1718. Okay, next subsection is the color. And this is a picture I grabbed from Zenfolio that David Lee took this summer. No, September 2022, that's it. And I really pushed the color so that you can see that Aldebaran is really like Mars and is much, much redder than the Pleiades. The Pleiades are a bunch of very hot, very young stars. Mars is rusty. That's why it looks red. What's going on with Aldebaran? Why is it such a red star? And if you take a look at the 25 brightest stars, what do you have? You have Arcturus, Betelgeuse, Antares, and Aldebaran. Those are the really of the major, the big stars. Those are the red ones. What's the deal with that? And the deal is actually extremely important in the history of modern physics, because they, once they started figuring out something about how electrons, well, they didn't know about electrons, but they knew about atoms. And this is in the 19th century. And they were figuring out about radiative transfer, how light interacts with matter and all this. But whenever they tried to work out what the spectrum of a hot glowing mass is, they kept coming into what we now call the ultraviolet catastrophe. As you get to smaller wavelengths, you would expect just to see more and more energy until it actually becomes infinite as you get through visible light into the ultraviolet. And that doesn't happen. What happens is there is a peak. It's low at very long wavelengths, and there's very little energy at small wavelengths. Anyway, so I just listed off some of the big stories here. So yeah, 1791 is when they start thinking about radiative heat exchange, and Kirchhoff invents this idea of the black body, and Stefan, he started measuring these curves. What I really want to get to is this the Willem Vine, the color temperature law, that as a star or any hot object gets hotter, you go from red to a white star. It's not green, even though it's kind of peaks in the green, because all the colors of the rainbow are here. And that's not a coincidence. Our eyes have evolved to work in sunlight. The outside of the sun is 5,300 Kelvin, and our eyes have tried to maximize the use of the light that's available here on Earth by splitting up the spectrum from red to blue where the light is brightest. But then a blue star would be much, much harder. A red star is going to be much, much cooler. And Aldebaran then turns out to be around 4,000 degrees. That's what I want to get at. Okay, now let's talk about the spectrum. And this is some amateur, Astrojolo, published this one. And this is what Aldebaran looks like when you pass it through a diffraction grating, but similar to a prism. And what you see is you get the continuum, you get all the colors of the rainbow, but there are these frequencies or these wavelengths that's missing it. I'm focusing in on this yellow guy here, and this is what it looks like in the graph. That's the only one that I know by heart. That's sodium. Sodium has this very, very distinct pair of yellow, they're called spectral lines. But this comes from the glowing bodies give off a continuous spectrum of light. If you heat up a gas of a particular element, then you don't get that discrete thing. You get individual lines, and they have to do with the atoms, the electron energy levels around atoms. And I didn't tell you about the importance of blackbody radiation and how physicists figured out that you don't get infinite energy coming off glowing bodies that in the ultraviolet. And it's because of quantum. The quantum theory came out of blackbody radiation, and it was Max Planck who said, if energy can't be continuous, but actually is in these little bundles that he called quantum, then you can explain blackbody radiation extremely accurately. Anyway,
it avoids the catastrophe.
It avoids the ultraviolet catastrophe. Anyway, the other important thing is that if you have a gas in front of a glowing mass like a star, the gas will absorb certain frequencies. So you get absorption lines, not emission lines. Okay, so this you can see my little pencil as I was reading the book. I really like this little point. At this point in the proceedings, spare a thought for poor old Auguste Comte, the first real philosopher of science, who as late as 1835 had suggested that both the chemical composition and the surface temperatures of stars would be forever unknowable. So I found the quote, and it's really very explicit. He was saying how they're just things that people will never know, because he thought at the time to know the density or the composition of a star, you were going to actually get a piece of it, and they were too far away. And it was one of those times that a scientific fact is so beautifully and clearly wrong. I mean, it made sense for him at the time, but we know so much about stars because of their spectra. And why do we know about this? It's because William Huggins was this very clever person who understood that you could use the physics that is being seen in the lab here on Earth to understand stars. It's remarkable. Before this, it wasn't clear that the stuff of the stars is the same as the stuff on the Earth. This is a huge, huge realization. And so in this paper, you had Huggins and Miller. They built a telescope with a prism to break up the colors of the light. And their very clever thing is, through the same prism, you also have a place where you can heat up a gas and make emission lines. So you don't have to worry too much where, if the temperature is different, or if you don't put the photographic plate exactly at the same position, it self-calibrates because you know the frequencies of the lines in your lab, and then you look at where the lines are in the image. And this is not the actual Huggins and Miller's paper has tables. It doesn't have any illustrations. So this is a picture that I stole from the Plaskett telescope, but it's the same idea. And so they looked at Aldebaran and they compared it to 16 terrestrial elements, and they found that 9 of them, sodium, magnesium, hydrogen, calcium, iron, bismuth, tellurium, antimony, and mercury, are exactly the same on this distant star as here on Earth. So again, this is a revolution in scientific thought because it is the first time that it was shown that the stars are made, or the Earth is made out of the same stuff as stars. And it really kind of ties things together in a most delicious way. A question, Vince.
I have a question. So when you're talking about it's the same stuff, are we talking about the same proportions as the Earth as far as like percentages of different
That's
minerals?
also a delicious story,
Okay.
which I think we're going to get into as I go through this book.
Okay.
But the simple answer is that the universe is mostly hydrogen and then helium. And here on Earth, those are volatiles and they escaped.
Yeah.
And so we have the siderophile and the lithophile elements, but we don't have the volatiles. Anyway, that's a super question, really important.
Yeah, like I'm just wondering if it's the same metallicity as Earth or even our own sun, or
The relative abundance of the elements
Yeah.
can be determined by the width and the depth of the absorption lines of the
okay.
Yeah, I mean what's her name from Harvard who wrote her thesis? Payne.
Celia Payne.
Is Cecilia Payne related to you? Or is that a different family?
To me?
Yeah.
Maybe.
If you shake the tree hard enough.
I'll say yes.
Okay, do some genealogy. Anyway, that's Aldebaran.
Very good. Well, thanks very much for that, Randy. We're getting close to the end here. I'd like to thank all of the people who have made presentations, Is there anyone else who has anything they'd like to add tonight?
Yeah, I'd just like to say I'm late to this party because I was out observing the naked eye comet, Leonard. From out here, by about 7:15, you could see it as a fuzzy patch in the sky. And in my 4-inch refractor, it was so cool.
And Bill, when you're naked eye, are you naked eye? Like you don't wear glasses or
Well, I'm using corrective lenses to make my glasses be my proper vision. But
where's where in the horizon is that, Bill?
It's between Serpens and Ophiuchus.
You're very impressive, Bill.
Oh no,
Okay.
everybody's been saying it's naked eye. It's out there in reasonably dark places.
It is Comet Swan.
Swan. Okay.
Yeah. So
No, this is Comet Leonard.
Oh, Leonard.
No, this is Leonard. This is not Swan.
Oh,
It has a fantastic tail. It's like crazy. It went well. It stretched right across the field of I have no idea what the field of view is, but a 31 Nagler in my NP 101. So that's probably like about a 4.5 degree field.
Oh, at least.
Yeah, we were looking at images of it earlier, Bill.
Yeah.
Turn over to it.
Actually, I think we were looking at Lemmon earlier.
We were looking at Lemmon. How come people are talking about Lemmon and Swan?
Maybe it's Lemmon. I don't know. I can't read. So
Oh, then it's Lemmon then. Yeah, okay. I wasn't sure about Leonard. But,
that's funny.
It says that Leonard was here in 2021.
It is Lemmon. Okay, yeah. 2025 A6 Lemmon. Yeah, that's it.
Go there.
Sorry.
Let's go.
Fairly low on the horizon in the northwest. Is it?
Oh, no, southwest. Was sort
Southwest.
of wherever, I don't know. I was running a line. It was like almost halfway in between Arcturus and the moon. And I could barely see any stars, but I could see those. And then I started panning around. Then I started picking up using my binoculars. And then I picked it up just before 7 o'clock.
Yeah, that makes sense that it's moving because the times that we saw it in previous weeks was closer west, I guess, southwest, I guess.
I was observing it in the early morning hours, but it's moving about 4 degrees a day. So it's really barreling along there. So this is wonderful news. So it's having a new lease on life, this Comet Lemmon.
Yeah, well, just hope for clear skies.
Yeah, I had to shut down because I had to come home for supper. And then as well as the Scotch mist was starting to come across the cricket pitch. I could see it heading, like it just kept getting thicker and thicker.
Yeah. So, well, thanks for sharing that. I think we'll sign off now, and I'm sorry for the technical difficulties we had in the presentation. We're blaming that on as a divine intervention from Sid. So for that, thanks again to all the presenters and the people who made comments about Sid. Appreciate that. And we'll be back here next week. And I'm not sure who is going to. Lauri is hosting. And
Catherine Whitney will talk about the concert that the Newcomb Singers are doing on December 13 and 14. And she is going to make a request for photographs from the club to illustrate the concert. And that'll be fun.
And can I just say for next week that I am coming back from Seattle in the morning, so that if there's a great big huge massive windstorm and the clipper can't come and can't bring me home, then I might not be able to do it, but I'll let somebody know if there's a major storm and I'm having trouble with getting on. Okay, I'll let somebody know. Otherwise, I'm fine. So.
Okay, and one last thing, reminder, it's the Astrophotography SIG on Wednesday night, and details are available from Dave Payne. Thanks very much, everyone. We'll see you next week.